placed into the live stream at the tone.
Hi there, I'd like to welcome you all to Getting Started with Microsoft Azure. My name is Steve Plank. Nobody actually calls me Steve Plank or even Steve. Everybody calls me Planky, and you should too. I've been Planky since I was 5 and I can't see that ever really changing. So my Twitter handle is @Plankytronics with 2 X's because I try to be arty and creative. Ha! Does that really work? Right, so let's get stuck into the material itself, and let's start off with the cloud landscape. So what is the cloud landscape? If you look at the on-premises landscape, it consists of servers which will typically follow this stack. Networking, storage and servers at the bottom. Sometimes virtualization, sometimes not. I'm sure you guys have probably got a mixture of those two environments. And then from that point upwards, you've got the operating system, like Linux or Windows. Middleware runtime, you've got things like web servers, application servers, platforms like Java, .NET and so on. And then data and applications on the top. If you think about where the value is in the application right at the very top, and the rest of it is a necessary evil. You have to do the rest of the stuff. It's absolutely captivating, it's absolutely interesting, I love doing it, but it's just a necessary evil. If you compare the management of that entire stack with what you would find on a public cloud provider like Microsoft, Google, Amazon, Rackspace, although they're not so much into this into the cloud anymore, more hosting, SoftLayer, one of these sorts of organizations, then you would find that infrastructure as a service, IaaS, really what they do is they take away the responsibility for managing the networking, the storage, the servers, and the virtualization. So you're still responsible for the operating system, the middleware, the runtime, and of course, your data. Your data model is down to you. Your application, any bug in your application is down to you to fix. But of course, things like the runtime, the middleware, and the operating system need to be patched. They need to have service packs applied. They need to have fixes put onto them. They need to have the updates done and all those kinds of things, so that when an emergency security vulnerability is identified and a fix is produced, it's up to you to make sure it gets onto the server pretty damn quickly. Okay, let's contrast that with PaaS, Platform as a Service, and this is where basically all of the responsibility for the infrastructure is taken away from you entirely, and all you worry about is the application and the data at the top of the stack. Clearly, if your application's got a bug in it, it's up to you to fix, to write the bug, write the fix, and apply the fix to the running application. Same with data. If there's something wrong with your data, it's up to you to fix it. Obviously, the operator, it doesn't know the internals of your application or your data. But they do know how to run operating systems, so they know how to keep them up to date. They do know how to do failure management. They do know what to do if you've got a large load balanced application. If one of those servers was to fail, they know how to take that out of the configuration and replace it with a new good running server. So that's what PaaS is. So if you look at the difference between IaaS and PaaS, what you can really see is that IaaS is great because it almost mimics the on-premises environment. So it's great for migrations. You can do very fast migrations. I mean, literally a number of hours in some cases. Well, in some cases, a number of minutes. You can literally copy the virtual hard drive from your virtualization stack across to the IaaS environment, hit the go button, and 5 minutes later you've got a server up and running. The disadvantage of it, of course, is that you only get rid of part of the ongoing maintenance and management. The advantage of PaaS is that you get rid of almost all of the ongoing maintenance and management outside of what your application and data require. But the disadvantage is that you have to write applications to run in this environment. It has a very specific way of running, as scale out, load balanced, stateless, that type of an application. So modern applications tend to be written in this way. And then there's another type of cloud service called SaaS, which is really talking about where the entire application is packaged up and delivered to you over the internet as a complete going concern. So an example of that would be Office 365, Salesforce CRM, Dynamics CRM Online, something like that. The entire thing is delivered to you. Now, bear in mind what I've just said about IaaS and PaaS. What we find is that as a general rule, IaaS is really interesting for the IT pro because it's about migrating. It's about migrating what you have to somebody else's data center. PaaS is really interesting for the developer because it allows them to concentrate on the application and not on the underlying infrastructure. Somebody else does that. Okay, now the reason I mentioned those two things is because the colouring in department at Microsoft, they like to call themselves marketing, but the colouring in department at Microsoft, they're likely to mention these things, PaaS and IaaS, because Gartner has put Microsoft as the leader in 4 magic quadrants for 4 reports that they've made. Cloud Infrastructure as a Service, that's IaaS. Enterprise Application Platform as a Service, that's PaaS. Public Cloud Storage Services, and x86 Server Virtualization. So Microsoft is the only company that's the leader in all 4 of those magic quadrants. In fact, if you look at a number of these reports, Microsoft is the only company, I think Microsoft may well be the only company that appears on all 4 of these reports at the same time. Most other companies don't. Okay, so I've done my little bit for marketing now. Let's move on to talking about the services themselves. Now, Azure consists of a massive, massive range of services. It's becoming really difficult to stay on top of them because last week a whole slew of new announcements were made about new releases. There's something like 400, something like that, between 300 and 400 announcements made per year for the speed at which stuff is being released. And it used to be every 3 months, and then it went to every 2 months, and now it's just like all the time. There's just a constant release of new services and new features. Some of that consists of stuff that runs in our data centers in the cloud. We've got, for example, the closest one to the UK really is in Dublin, or you could say Amsterdam in some cases, depending on where you live. And all the stuff in green on this slide lives in a cloud data center. All the stuff in purple is the sort of stuff that you might use. You might use SDKs and APIs and so on in the devices that you use in your on-premises environment. And you might link the whole lot together. You might link server infrastructures together using a whole bunch of other services as well. You pay for these services, for compute, for example. If you have a virtual machine, you'd pay for that per minute that it was running. Cloud service, a mobile service, like a mobile backend or a website, you'd pay for that per minute. Databases, you tend to pay for those, depends how they're running. If it's a database which is just a SQL server, something like that, running on a VM, you just pay for that as part of your VM charges. If it's a database service that we offer, like SQL DB, then you pay for the performance that you're getting. You pay for the capacity of the unit. If you pay per storage, you pay per gigabyte per month for that. So each one of these different services has its own ways of charging. Now I'm going to concentrate from this point on, not on this whole picture because we'll never get through that in an hour. I'm going to concentrate on just a small section of this, which is 4 components, and it's the compute components. I'm going to concentrate on virtual machines, websites, mobile services, and cloud services. I'm sure you all know what virtual machines are, but the other things will require some explanation. Okay, so when you look at the infrastructure, the data center buildings that we operate are all about the size of a football pitch. And that means that you can get 2 jumbo jets into one of those football pitches. It also means that we bring 16 of these buildings together, and that would make what we call a region. And there are a number of regions around the world. Now, in each of these regions, that means we can have up to 600,000 physical servers in each Azure region. That you can imagine how many VMs that equates to, many millions of VMs. We're talking really here about massive hyperscale operations here. There are only really 3 hyperscale operators in the world. That's Amazon, Google, and Microsoft. But this is just a slide to give you some idea of the absolute size of Microsoft's operation. Remember what I said, each of these data centers consists of lots of buildings, hundreds of thousands of servers, and you can see there are 1, 2, 3, 4, 5, 6, 7, 8 in the US, 6 public ones and 2 purely for the US government. Only the US government can use those 2. You can see there's 1 in Brazil. You can see there are 2 in Europe. One's in Dublin, one's in Amsterdam. You can see 2 that are to be decided in India. They'll be coming soon in 2015. You can see 2 in Southeast Asia, Hong Kong and Singapore, 2 in China, 2 in Japan, and 2 in Australia. So that gives us 100 plus data centers. It's one of the top 3 networks in the world for coverage, speed and connection. Double the AWS and 6 times Google's number of offered regions. And we're also offering today a 32 core, 448 gigabyte RAM SSD VM. You have to be on a preview to get access to that, but that will become generally available in a couple of months' time. That's not all. So that's the absolute. With each of these data centers, we're talking about $2 billion worth of investment. So they're massive, massive, massive bits of infrastructure. That's not all, because we've also got a CDN network, a content delivery network, and if you look at this diagram, it shows you wherever there are centres of population around the world, then we have a CDN endpoint too. And what that means is that you can get your content to your users wherever your users are actually located, so they don't have to suffer long delays while they're waiting for web pages to build. So that's the kind of the broad infrastructure. If we drill down inside an individual data center, then we've got 6 generations of data center: Gen 1, 2, 3, 4, 5, and 6. Gen 1 data centers, they're what you're familiar with. You walk into the building, and it's very loud. There's lots of fans running. It's nice and cool. There's lots of flashing lights, lots of racks, lots of aisles that you walk up and down. That kind of thing. Then you go to Gen 2 and Gen 3 data centers. You basically find higher server density. You find customization of the equipment that is used, and you'll find more servers per square foot. And then you get to this really interesting one, which is called the Gen 4 data center, which uses IT packs, IT pre-assembled components. And they rather resemble 40-foot shipping containers. In fact, they fit onto trucks and cargo vessels in the same way that 40-foot shipping containers do. They're not 40-foot shipping containers. They're customized bits of equipment that do a very specific job. I'm just going to show you a video of how they're built in a Gen 4 data center. So we start with framing and flooring, server racks, transformer, partitions, fans, exhaust dampers, bus bars, servers, lights, mixing dampers, air washer, drain pipes, air washer supports, air washers, intake louvers, filters in louvers, skin, and you've got yourself a 2,500 server container operating at 90 degrees Fahrenheit. A human being will never go inside this container, and we'll make 3 connections to these things: power, data, and non-potable water for cooling. Look at these data centers. Look, this is a Gen 4 data center. All the stuff is outside. It doesn't live inside a building. Each of these units is hermetically sealed, and the human being will never go inside them and never need to. The sort of thing that happens is the container is the replaceable unit. So we'll wait until we got a couple of hundred failures in there, and then that'll be the trigger to. It might be 300, it might be 100, but we'll hit some threshold, and that will be the trigger to cause a swap to occur. And so we'll move all the workloads off the container. We'll disconnect the 3 cables, the water, the cooling, the power, and the network, and we'll then crane it out, crane a new one into position, connect those 3 connectors up, allow the software to install itself onto all the machines that are running in there, and then we'll start putting workloads onto it. So there you go. It's a complete, the swappable container is the swappable unit is no longer the power supply or the hard drive. It's now the entire shipping container containing 2,500 physical servers. Okay, that's interesting. Now, you might have noticed in this video that in the distance there were some buildings that looked rather like hangars. They had a rather data center look to them, and those are the Gen 5 and Gen 6 data centers. And the difference between those is that the racks do live inside a conventional building. They'd be much more sort of normal looking to you. But what you find there is a very, very customized environment. Racks that are built especially for the environment. Circuit board, the servers don't come in pizza boxes. They are specifically built for Microsoft. And the distance between, you think of things in terms of U's, don't you? The unit of height, essentially. But you don't think of that in these Gen 5 and Gen 6 data centers. You think of the massive number of servers that they can get in per square foot by customizing the whole environment and having the servers built by a specialized manufacturer for Microsoft. Okay. That's doing the video again. That's a bit strange, isn't it? I don't know why that is. Let's move on. So, as far as data is concerned, then we have in this picture 2 data centers. On the left is Dublin. On the right is Amsterdam. Notice in each data center there are 3 racks. At the top of each rack is a top of rack router, and we've got disks in each one. I mean, there's lots more disks than I'm showing here, but this is just to give you an idea. Whenever you write data into a data center, you get 3 copies of your data, and they're spread across 3 racks, across 3 separate fault domains. So each one of these racks will be on a different network segment, a different battery backup unit, a different power unit, a different cooling part of the system, so that if you were to, you can see the way your data is copied. It's specifically copied across 3 separate fault domains, so that if you were to lose one copy of your data, something was to go wrong with that copy of your data, then that's okay. If we had a cooling failure, then it would only affect that middle rack, or if we had a network failure, then it would only affect one of the racks. That's okay, because what it means is when we eventually fix that bit of subsystem, then we can get your good. We'll mark the disk as bad, but we can get good data from elsewhere in the system. And that's what we've done there. So we've still got 3 copies of your data. Now this still looks a little bit dodgy because it's all in one data center. So to protect against that, we have geographic replication to another data center which we're paired with. Every data center in the world is paired up with another data center somewhere else in the world. So the 2 in Japan are a pair, the 2 in China are a pair, the 2 in Australia are a pair, the 2 in Southeast Asia are a pair, the 2 that will be in India will be a pair, the 2 in Europe are a pair. There are 8 in the US which are all paired up as in sets of pairs, and the 1 in Brazil is paired up with South Central US. So what that means is whenever you write your data into another data center, you get 3 copies of your data. So now you've got 6 copies of your data spread across 2 geographically separated bits of infrastructure, which would mean you'd need an absolutely massive, I don't know, an earthquake that spanned the globe or something like that to lose all 6 copies of your data. So you can really think of your data as being very, very safely managed when you move it to the Azure environment. Okay, now how do you get to try all this stuff? Well, you can actually try it for free. So there are a number of free trial subscriptions you can take out. If you go to each one of these URLs, the free trial gives you 30 days and $200. So if you spend your $200 before your 30 days are up, then your free trial is expired. You can at that point convert to a full pay-as-you-go subscription by removing the spending limit. You have to physically remove the spending limit. By default, it's set to 0.00. If you're an MSDN subscriber, then by going to that URL, you can add Azure benefits onto your MSDN subscription. So you can get up to $150 per month to spend on Azure. If you're a BizSpark business, you go to that link and you can have up to $150 per month to spend on Azure. And if you're an MPN partner, then you go to that URL and you can get some resources as well. I see I've got some questions coming in here. Somebody says, I appear to be getting crosstalk from another webinar while viewing this event. Any advice on how to get a better experience? I have no idea. Is it? Could you maybe? This is from Paul. So Paul is saying he's getting crosstalk from another webinar. I suppose the first question I could ask is, could any of you just type in there to say that some of you might be getting the same thing? That would give me a clue. And could any of you tell me whether it's a doubling up of this webinar? Somebody's answered the question by the look of it. Just refresh the browser. Well, that's a bit of advice there from somebody. That's great. Okay, let me move on.
Signing up to a free Azure trial is simple. First of all, log into your Microsoft account. This is what used to be called a live ID. If you've got an @hotmail.com, @live.com, or @outlook.com ID, use that. If not, to get a Microsoft account, go to signup.live.com and you can sign up for one there. Once you have it, go to http://aka.ms/mscloudtrial. That will take you to this page where you click the Try It Now button. You can see here it's already extracted a little bit of information about me from when I logged in using my Microsoft account. I need to enter a telephone number, and I should expect either a text message or a call depending on what I selected. They'll give me a special one-time code. Now this is part of the anti-fraud measures. After I've clicked the Send button, I need to get hold of the number they sent and type it into the Verify code box and then click the button. I can now enter credit card information. Now you will not be charged. Your spending limit will be set to 0.00. This is just an additional anti-fraud measure. An identity check is done using the card. This just ensures you aren't an anonymous person who wants to use the service for some kind of criminal or illegal purpose. So it's now just a case of simply filling in the credit card information. Once that's done, agree to the terms and conditions. And in this case, I bail out of receiving marketing communications and then click the Sign Up button, which is now complete. Now click the Portal button in the top right corner and you come to a little welcome wizard. You might want to read these items, but I'm skipping through because I've read it all before. You're now logged into the Azure portal. You can see your credit status in the green box at the top of the screen. This is not money you have paid. This is the free amount of credit Microsoft gives you as part of the free trial. That's it. You're done. Now, anytime you want to get back to the portal, for example if you want to create a website, just go to http:// manage.windowsazure.com and log in.
Great. Okay, so I answered a few questions there that people were asking about. Some of them were getting. I think some of you were getting that video cross-talking with the current audio channel at the same time. And I can see that somebody there has got a problem. Richard seems to have a problem with wondering what is playing right now. I had that playing while you were speaking. I'm really sorry, I can't help you with that right now, Russell. It looks like Janet, one of my helpers from On24, is probably going to help with that. So I'm going to leave her to talk you through that through the answer channel. I pushed the answers out to everybody saying thanks for letting me know, because it's just interesting to know when little things go wrong so we can fix it for the future. So thanks very much for telling me that. That's very good of you guys. Okay, what I'm going to do now then is I'm going to do some demos. I've got basically 5 demos to do. Building a WordPress website, building an ASP.NET website, creating a server. I'm actually not going to create a server. I'm going to create a dev workstation. It's going to be on Server 2012, but I'm going to create a dev workstation. Creating a cloud backend for a mobile app and creating a cloud service. So I'm going to kick off by sharing the screen and creating a virtual machine. So let me just go into screen share. It takes me a few moments to just get this set up because I've got to get it sized and so on. There we go there. I'm just waiting until you guys can see it, which I think you probably can now, I think. Right, so what I'll do is I go to, that's the wrong subscription. Let me go to this. No, sorry, that was the right subscription. Right, so I go here and I say new virtual machine. Sorry, what I should just explain before we go in. This is the Azure Management Portal. So you log into this portal and you can manage virtual machines, websites, storage, SQL databases, service bus, cache, and so on. I'm going to do virtual machines. So I log into this and I say new virtual machine